Hello everyone and welcome back. In this new section of the course, we're going to talk about user authentication. Authentication is one of those common use cases that benefits from some front-end state management. In the concrete case of our application, we don't have any authentication use cases implemented yet. So we can see here on the menu sidebar that we have here a login screen that the user will be able to use in order to perform a user login. We already have here some predefined values in our login form, so we would expect whenever the user clicks here on the login button for the login to be performed and for the user profile to be made available to the front end. We want to make sure that things such as the login or the logout button are shown or hidden from the user depending on the user authentication state. Also, whenever the user reloads here the browser by clicking on the refresh button, we would like to keep the user logged in without asking the user to submit its password again via the login button. So we would like the authentication state on the front end to survive browser refreshes. In general, we want to keep the user profile after the user has performed its login, and we want to save it in some centralized place in our application where we can easily access it from anywhere where we need it, from the top menu of our application or from any other component that needs to know if the user is logged in or not. This could be anywhere in our application, so we want to adopt, for the case of the authentication user profile, a centralized state management approach. Let's then, in the remainder of this lesson, talk about the design of our front-end authentication solution. So we are going to be having here a new store service, as you are probably already imagining. We are going to create here under our services folder a new file that we are going to call auth.store.ts. Let's now define the skeleton and the public API of our authentication store. We are going to start by defining here a new class called authStore. Let's make this class an Angular injectable. Now let's talk about the scope of this injectable. So because the authentication state needs to be available to the whole application, we are going to make the authentication store a global singleton by defining here the provided in property with the value root. Let's now talk about the public API of the authentication store. The authentication store is going to keep in memory the value of the user profile. So if we open here our application model folder, we're going to find here a user model. So this defines the user profile, which will contain an email and a picture URL that we are going to be displaying here in our application when the user is logged in. So going back here to our authentication store, let's now use the user interface in order to define the public API of our store service. We are going to be defining here a public observable, which is going to be the user observable. This observable is going to emit as values the user profile from the model folder. So any part of the application that needs the user profile, for example, for determining if the user should see a login or logout button, can then get a reference to the user profile observable by injecting in its constructor the global authentication store singleton. Let's now continue to define the rest of the public API of the authentication store. So in a similar way to exposing here the user profile, we are also going to be defining here a new observable called isLoggedIn. This is going to emit Boolean values. The value true is going to be emitted if the user is currently logged in, and the value false is going to be emitted if the user logs out. We are going to also be exposing here another observable, which is going to be the isLoggedOut observable. This is going to work in a similar way to isLoggedIn, but the opposite values are going to be emitted. So isLoggedOut is going to emit true if the user logs out, and it's going to emit false if the user logs in. So these are the three observables that we are going to have available here as part of the public API of the authentication store. Next, we are going to be defining here another method, which is going to be part of this API, which is the login method. This is going to be called by the login screen. So we are going to be passing as the input arguments of this method an email and a password. Both these arguments are strings. We are going to be returning as the output of this login method an observable of user. So this observable is going to be emitting the user profile when the user logs in, and it's going to error out in case that the login is denied. Another method that we need to add to the public API of store is going to be the logout method. This will take no additional input arguments. At this point, we now have here the initial version of the authentication store. We have defined the public API of the authentication store. Let's now, in our next lesson, talk about the authentication store internal implementation. Hello everyone and welcome back. In this new lesson, we're going to take care of the internal implementation of our authentication store. Let's start by defining what do we want to implement. We want our authentication store to be able to emit a new value for the user profile whenever the user logs in successfully by calling our /API/login backend service. The backend service is going to validate the correct email and password combination, and it's going to get us back a user profile. We want to emit that to the rest of the application so that, for example, the home component or the application component can, for example, show or hide here the login and logout buttons depending on the user authentication state. We also want to store this user profile in local storage so that it survives user refreshes. So whenever the user reloads the page, you will not have to log into the application again. The login state is going to be preserved and survive refreshes. So this authentication store needs to emit new user profiles whenever the user logs in, and it needs to store those user profiles on local storage and retrieve the user profile from there at application startup time. Let's now see how the user observable, which is the main observable of our public API, is going to be implemented. So as usual, we are going to be implementing this observable using a private subject. This subject is not going to be accessible to the rest of the application because it's the subject that can emit new values of the user profile. And we want to keep that capability private and inside this authentication store. So the values emitted by this subject are going to be user profiles. The initial user profile is going to be null, meaning that the user is not yet authenticated. Let's now see how we're going to use the subject in order to define the user observable. As we have done before in our course, we are going to be calling here our subject and we are going to call here as observable. So our user observable is going to emit the same values as the subject. Let's now see how we're going to be defining the isLoggedIn and isLoggedOut observables. We want to define these based on the value of the user observable. So at application startup time, let's go ahead and define these two observables here in our constructor. The isLoggedIn observable is going to be derived from the user observable. We are going to be deriving this using the RxJs pipe syntax. And we're going to be applying here the RxJs map operator. We are going to receive here the user profile emitted by the user observable, and we're going to transform this into true if the user profile exists. So let's use here double negation. We are going to do a double negation of the user. So this is going to convert the user to true if the user exists, and if the user is not yet logged in, this is going to be converted to false. So with this, we have defined here the isLoggedIn observable. Let's now define isLoggedOut. We are going to define the isLoggedOut observable based on the value of isLoggedIn. Let's use again the RxJs pipe syntax. We are going to use again the map operator, and this time around we are going to take the flag emitted by isLoggedIn that we are going to call simply loggedIn, and we are going to negate it. So this observable here is going to emit true if isLoggedIn emits false and vice versa. Now let's see how we're going to implement the main functionality of our authentication store, which is to perform the user login. So our backend service has an endpoint/API/login that we need to call with the user email and password in order to validate if the login is valid or not. In order to make that HTTP call, we're going to be injecting here the Angular HTTP client. Let's then use the HTTP client in order to perform our HTTP call to our login service. We are going to be calling here the HTTP post method, and now we are going to be calling the /API/login endpoint. To this endpoint, we need to pass in a JSON payload containing two properties, the email and the password. Our service is then going to validate if this email and password combination is correct, and if that's the case, we are going to get back here from the backend a user profile. Let's pass in here as a generic argument the type of data that we are expected to receive from the backend, in this case the user profile. We can now go ahead and return this as the output of our login method. As usual, we want to avoid that multiple subscriptions to this returned observable result accidentally into multiple calls to our login endpoint. In order to avoid that scenario, we're going to be using here the RxJs pipe syntax, and we're going to be applying here the RxJs share replay operator. And with this, we have an initial implementation of our login service. Let's now go ahead and implement logout. So whenever the user logs out from the application, we want to emit again here the null value. This will report to the rest of the application that there is no longer a user profile available. So isLoggedOut is going to emit the value true. In order to do so, we're going to access here our private subject, and we're going to call next on it, and we're going to emit the value null, meaning that the user has logged out. Let's now complete the implementation of the login operation. So here we are doing an HTTP post to our backend, and we are getting back the user profile. Besides emitting this user profile to the caller of login via this returned observable, we also want to emit this user profile via the user observable. So for that, we're going to be doing a side effect via the tap operator. Here we are receiving the user profile, so we now want to emit this as a new value of the user observable by using the subject. Let's call next on this subject, and let's pass in the user profile that we got from our backend. So this way, the user profile is going to be emitted via the user observable, isLoggedIn is going to emit the value true, and isLoggedOut is going to emit the value false. In a similar way, whenever we do a logout here, we are emitting here the null value in our user observable. This means that isLoggedOut is going to emit the value true, and isLoggedIn is going to emit the value false. And with this, we have now completed the initial implementation of our authentication store. Let's now see how the store observables are going to be consumed by our application. Hello everyone, and welcome back. In the last couple of lessons, we have defined the public API of our authentication store service, and we have defined the initial implementation of the login and the logout methods. In this lesson, we are now going to see how the authentication store is going to be used by the rest of the application. So the first part of our application that needs the authentication store is the login screen that is accessible when we click here on the login button. This login screen corresponds to the login component that we see here on the screen. If we check here the template of this component, we can see that this has a form with two fields, the email and password field, that correspond to what we see here on the screen. And whenever we click here on the login button, we are going to trigger here the login method of the login component. Now here in our value constant, we have here the form value containing the email and password fields. What we want to do is to send this to the backend in order for the combination of email and password to be validated. If the password is correct, we are going to get back from the backend the user profile that we're going to be saving on the store. So in order to call our backend authentication endpoint, we are going to inject here our authentication store. Using the authentication store, we are going to be calling the login method, and we need to pass it the user email and password. So let's pass first the email, and now let's pass in the password. We are going to get back from the login method an observable that we need as usual to subscribe to, otherwise nothing will happen. Now let's see what will happen if the login is successful. If that is the case, then we are going to navigate to our courses page. We are going to be doing that using the Angular router that we already have here injected in our constructor. Let's then go ahead and call the router. We are going to be using navigate by URL, and we are going to access the screen /courses. Now, what happens if the login fails? In that case, we are going to be showing to the end user an error message, and let's simply use a JavaScript alert box. Let's simply say that the login has failed. And with this, we have implemented the login logic. Let's now take a moment to implement also the logout logic. The logout is going to be implemented here via this logout button in our top menu. The top menu is implemented in our application component. So if we open here our application component template, we are going to see here in our sidebar by scrolling down that indeed we have here the logout button. The logout button is going to trigger here the logout method whenever it gets clicked. Let's then go ahead and implement here the logout logic. In order to perform a logout, we need to inject here in our constructor our authentication store. Using the authentication store, we are going to call the logout method on it. And this is going to trigger a user logout. Now let's see how we are going to be using the authentication store in order to decide which buttons to show to the user here in our top menu. So we have here a login and a logout button that we want to show to the user only if necessary. The user will be either logged in or logged out. So at any given moment, we are only going to be showing to the user one of these two buttons, but not both as we see here. In order to decide which button should be shown to the user, we are going to be using the isLoggedIn and the isLoggedOut observables. So going back here to our application component, let's open here the template and let's identify the login button. We can find it here, and here is the logout button. Now let's think about in which conditions should the login button be displayed to the user. Let's apply here the Angular ngIf directive, and using it we are going to show the login button to the user only if the user is still logged out. Let's then access here our authentication store. We're going to access here the isLoggedOut observable, and we're going to subscribe to it using the Angular core async pipe. The async pipe is going to subscribe to the values emitted by isLoggedOut. So if this value is true, meaning that the user is not yet logged in, then in that case and only in that case we are going to be showing the login button to the user. Let's now think about when should the logout button be shown to the user. We want to show the logout button only if the user is already logged in. Let's then apply here ngIf. Let's access here the isLoggedIn observable and let's subscribe to it via the async pipe. IsLoggedIn is going to emit true if the user is already logged in. So only in that case, when the user is already logged in, we are going to be showing to the user the logout button. Notice that we are accessing here the authentication store service directly via the template. Now, in order for this to work, we need to set this authentication store property to public instead of private. Otherwise, we are going to get an error whenever we try to run our program. Let's now try out the login and logout functionality. I'm going to switch here to a larger window, and here we have already refreshed our application. We are now running the latest version of our program. If we open here the side menu, we are going to see that because the user is not yet logged in, then we are showing the login button and we are hiding the logout button. Let's click on login, and with this we have navigated to the login screen. Now we have here a valid email and password pre-filled in, so in order to make it easy for you to take the course. So in the real production scenario, this form would not be pre-filled with a valid value, as you can imagine. Now let's clear here our network log and let's go ahead and perform a user login. I'm going to click here on login. This is going to call our backend. The user and password combination was valid, so our login endpoint returned us here on the response a valid user profile. This profile was emitted and the isLoggedIn and isLoggedOut observables emitted their new corresponding values. So if we now click here on our top menu, we are going to see that the login button has been hidden and we now have here available only the logout button as expected. If I now click here on logout, we are going to see that a new value is going to get emitted by our Authentication Store user observable and by the derived isLoggedIn and isLoggedOut observables. So if we now click again here on the top menu, we are going to see that the user is now logged out. So we now see again the login button and the logout button was hidden as expected. So everything is working correctly. There is only one problem. If I now log in here again, and I refresh the application, we are going to see that the user is now logged out again. So I'm going to open here the side menu, and as we can see, the login status of the user did not survive browser refreshes. This means, going back here to our program, that our current implementation of our authentication store is incomplete. This is an initial version, but on our next lesson we are going to be refactoring this implementation in order to enable the authentication state to survive browser refreshes as expected by the user. Hello everyone and welcome back. In this new lesson, we're going to adapt our implementation of our authentication store. Our goal here is to enable our authentication state to survive browser refreshes. So whenever the user clicks here on refresh, if the user is already logged in, then he should remain logged in after the refresh as well. In order to implement this very common use case, we are going to be using the browser's local storage, which is a small key value database that survives browser refreshes. On local storage, we can only store and retrieve strings. So we are going to be taking our user profile and we are going to save it in local storage under the form of serialized JSON. Then whenever our application starts up again, the first thing that we're going to be doing is to read from local storage the user state, and if the user profile is available in local storage, we are going to emit it here using our subject to any other component in our application that needs to know if the user is logged in or not. Let's then start by saving our user profile in local storage whenever it becomes available from our backend. So the first thing that we're going to do is to define here a storage key that we're going to name off data. So this is the key that we are going to be using to save and retrieve data from local storage. Let's assign some value to this key. Let's call it off_data. So this is the local storage key under which we are going to be saving the user profile. Let's now see exactly when will the user profile get saved to local storage. The best place to save the user profile is going to be here whenever we are emitting it to the rest of the application after we got the user profile from our backend login call. Let's then refactor here the implementation of the tap operator. We are going to keep this as the first line of our implementation. We are going to emit the new value of the user profile to the rest of the application using the user observable. But besides notifying the rest of the application, we are also going to be saving the user profile in local storage. In order for that, let's access here the local storage API and let's see how it works. As we can see, it's a key value database where the keys are strings and the values retrieved are also strings. In order to save the user profile on the database, we need then to call setItem. The first argument is going to be the key under which we want to store our information. In this case, we're going to be using our authentication data key that we have defined here in this constant. The second value that we're going to be passing to setItem is going to be the data that we want to save, in this case, the user profile. But notice that if we pass simply the user object, we are going to get here a compilation error. And this is because here we need a string and not a JavaScript object. So we are going to call here json.stringify, and we are going to convert the user profile into a string. And with this, we have saved the user profile in local storage, so the user profile will survive browser refreshes. Now, all we have to do is at application startup time, whenever the authentication store gets created, we need to check local storage, see if the user profile is there or not. And if the user profile is there, we should emit it to the rest of the application. We are going to be adding that initialization logic here in our service constructor. So here, let's call local storage. We're going to be calling here getItem, and let's pass in here the authentication data key. So the result of this call is going to be a string containing the user profile under the form of JSON. Let's assign then this to a constant called user. Notice that this is not a user object, a plain JavaScript object. This is a string because we have just retrieved it here from local storage. Now we're going to check if the user profile exists or not. If the user profile exists in local storage, then we want to call json.parse on the string that we have received in order to create an in-memory object. So this is the user profile that we want to emit to the rest of the application using our private subject. Let's then call here subject.next, and let's pass in the value of the user profile that we got from local storage. And with this, the user observable and its derived observables are going to be emitting the correct values at application startup time in case that the user profile is present in local storage. Now, all we have to do is to complete here the implementation of the logout functionality. So here, besides emitting here the value null in our user observable, we also want to clear the user profile from local storage. Let's then here call the local storage API, let's call remove item, and let's pass it our authentication data key. And with this, the implementation of our authentication store service is now completed. Let's then go ahead and test everything out. We are going to be switching to a larger window, and here we are going to navigate to the login screen. Let's now click here on login and confirm that indeed the login was correctly performed in our backend and that the logout button is present, and also that the login button is still hidden. We are now going to confirm that the user profile has been saved in local storage. We are going to be using the Chrome DevTools for that by selecting here the application tab. From here, we are going to click on local storage, and we are going to click here on the entry localhost 4200. So as expected, we have here an entry in local storage with key auth_data. And if we click on it, we are going to see that indeed it contains the user profile as expected. So now we're going to go ahead and refresh the application, and we're going to see that indeed the authentication data is still on local storage as expected. This means that now if we open here our top menu, we're going to see that the user login state has been preserved across refreshes. We can see here that the login button is hidden and that only the logout button is being displayed as expected. Now let's go ahead and perform a user logout and keep close attention here to the local storage tab. I'm going to open the top menu, we're going to click on logout, and notice that the authentication data key was removed from local storage. So now the user is logged out, meaning that only the login button is now visible. If we refresh the application, we are going to see that everything is still working as expected. If we click here on the top menu, we are going to see that the user is still logged out. And with this, we have put in place in our application a complete solution for authentication state management. As we can see, authentication is a good example of when we would want to add a little bit of state management to our application as opposed to keeping everything stateless. The problem with authentication is that the user profile is something that we're going to need in many places of our application. Calling the login service each time that we need the user profile is not practical, and so storing the user profile in a centralized store in our application is a much more efficient solution. This prevents us from calling the backend each time that we need the user profile, which would not be doable in practice because in order to call the login endpoint, we would need each time the user login and password. Let's now talk about another common use case for state management. We are going to introduce in our next section a new design pattern. We are going to be introducing the master detail design pattern, and we're going to see how in certain circumstances it benefits from doing some local state management. Hello everyone and welcome back. In this new section of the course, we are going to present another very common use case that benefits from some local state management. I'm talking about the master detail user interface pattern. In this lesson, we are going to go over a simple example of this master detail pattern. We're going to see that it's indeed a very common user interface pattern, and we're going to understand why it benefits from some state management. A typical example of a master detail pattern happens whenever we want to do a search, we want to display a list of results, and then we want to click separately in each of the search results and have a detailed view of the search result. Let's give an example. We're going to go here to our application top menu, and we're going to click here on the option Search Lessons. When we click on it, we are going to get to this Search All Lessons screen, which is not implemented yet, but we already have here some HTML and CSS as a starting point. This Search All Lessons screen is implemented here by the Search Lessons component that, as we can see, is currently still empty. So we only have here the skeleton of the component. So how will the functionality of this screen work? The user is here searching for a particular lesson. So as we type in here our search and we click on the search button, we are going to trigger a backend search for a list of lessons containing, for example, a certain word on their title. Once we get back from our backend that list of search results, we want to display them here on a table. So clicking here on our search lessons component HTML template, we can see that we already have here the skeleton of an HTML table that we're going to be using to display our search results. So whenever we get back the search results from our backend, we want to click in one of the lessons and we want to see the lesson displayed here on our screen, replacing the list of search results. Next, we might want to navigate to another lesson which is part of the search results. In that case, we want to press a Back to Results button. The search results should be displayed again, and the user can then select another search result from the list and view it in detail. So this type of user interface pattern, where we are displaying a master table that we can click and zoom in and see the entry of that table in detail in a separate component, is known as the master detail user interface pattern, and it's very commonly used not only for situations where we are displaying lists of searches, but in any situation in general where we want to have a master table containing a list of results that we want to then click on and view in more detail in a separate screen. As you can imagine, the master detail user interface pattern will really benefit from some state management, because this search operation that we are doing to the backend might take some time. So when we get the search results back and we display them here on the table, we want to keep those search results around in our front end. We don't want to necessarily simply transform those results into HTML and discard the data. And this is because whenever we click in one of the search results, we want to hide the search results table and we want to replace that table with a detail that shows us the item that was just clicked. So whenever we go back to the search results, we don't want to have to repeat the search again. Instead, we want to take the search results from an in-memory store and we want to display them immediately to the user without having to contact the backend again. In the next few lessons, we are going to then implement this very common use case. We are going to show you how to implement a master detail UI scenario with state management for the search results table. We are going to be doing this locally at the level of the search all lessons component. So the state that we're going to be creating in memory is not going to be global application state. Instead, this state will be specific to the search lessons screen. Hello everyone and welcome back. In this new lesson, we're going to start the implementation of the search all lessons screen. So the screen will follow the master detail user interface pattern. And in this first lesson, we're going to start with the master part. So we want to type here a search in our search box. We want to click on the search button and we want to trigger a request to the backend and display here a list of search results. The master table is going to be displayed here directly in our search lessons component, but the detail of each of the search results is going to be displayed by using the lesson component that we will be implementing later on in the course. So we will be storing the search results while we navigate through the multiple details. So the question is now, where are we going to store these results? In the particular case of this master detail scenario, we're going to choose to store our data directly here in a member variable at the level of the search lessons component. Let's then create here a new member variable that we're going to call search results. This is going to be an observable of lesson array, meaning that the values emitted by this observable are going to be lists of lessons that correspond to the result of one particular search. So as we can see, doing state management in an Angular application is not about using shared services, it's not about using behavior subject or even a third-party library to manage our state. We can also do state management simply by using member variables at the level of top-level container-like components, such as the search lessons component that corresponds to the page that we see here on the screen. Let's then populate search results with some data. If we go here to our search lessons component, we are going to find here an input that corresponds to this search input. We can see that it has the template name search input. So we are going to be using this name in order to pass the search that we want to do to our component. For that, let's start by detecting here the click event on the search button. When the search button gets clicked, we are going to be calling a component method called onSearch, and we're going to pass it the value that the user has typed here. Let's access here the search input and let's pass the search value to our search lessons component. Let's now implement the onSearch method. OnSearch is going to receive here a single input parameter, which is going to be the search string. And from here, we need to call our backend and populate here the search results member variable. In order to call our backend, we're going to be using, just like before, the courses service. Let's then inject the courses service here in our constructor as usual. And from here, we're going to be calling a new method, not implemented yet on courses service, which is going to be called search lessons. This method is going to take as input only one argument, which is going to be a search string. We are going to be returning here as the output of this method an observable that emits arrays of lessons. So these will be the lessons that match the search criteria. Our backend already has available an endpoint for searching for lessons. We can access that endpoint using the Angular HTTP client by doing an HTTP GET method to the endpoint /API/lessons. To this HTTP GET parameter, we're going to be passing in a couple of parameters. Let's pass in here a configuration object. Let's specify here a map parameters. And here we're going to specify our first parameter, which is going to be the filter properties. So here we are going to be passing our search string. And before adding here the rest of the parameters, let's fix here this compilation error. We're going to pass in here a parametric type that specifies the output of this call to http.get. So we're going to get back from the backend an array of lessons. So now we have here our first parameter. The second parameter that we need to pass to our backend endpoint is going to be the page size that we are going to set to 100. You will notice here a compilation error, and this is because all our parameters for an HTTP request need to be strings. Now let's complete the implementation of our search lessons method. So the result that we are getting back here from the backend does not actually contain an array of lessons. So we are getting back an object from the backend. So we are going to map this object, which is going to be our HTTP response. And from it, we are going to extract one property, which will be the payload property. We are also going to be applying here, as usual, the share replay operator in order to avoid that multiple subscriptions of our output observable accidentally trigger multiple repeated HTTP requests. Now that we have finished the implementation of search lessons, let's go ahead and use this new method here in our search lessons component. So here, whenever we click on the search button, we're going to trigger this method, and from here we want to access the courses service and we want to call search lessons by passing it the search string. This is going to get us back an observable that we want to assign here to search results. Now that we have our data stored in our member variable, we can go ahead and display it here on the screen using our HTML table. We're going to start by accessing the values emitted by the search results observable. And for that, we're going to be using ng-container in order to avoid creating here extra HTML elements. And we're going to use here the ngIf syntax. We're going to access search results and we're going to apply it the async pipe. And to this result here, which are the values emitted by the search results observable, we are going to assign a new template name that is going to be the lessons variable. Inside this ng container, we are going to apply our HTML table where we are going to be able to visualize our results. We have here the table header containing a few columns, and we have here the HTML for a table row. So let's go ahead and let's uncomment this, and let's apply here the Angular ng-for syntax in order to loop through our list of lessons. Let's then use here the syntax let lesson of lessons. And with this, we have used here the template for a row to display all our search results. And with this, we have finished the initial part of our master detail setup. Let's go ahead and try out this current version of our search lessons component. So here I already reloaded and we have here the new version of the application. Let's go ahead and type in here some search. Let's search for the word intro and let's go ahead and click search. This is going to trigger a request to the backend, and we have here all the matching lessons with the word intro on its title. So as we can see, everything is working as expected. Now, what we want to do now that we have here some search results, we want to be able to click in one of the results and see in detail what the search result corresponds to. So we would like to display here the lesson that we have just clicked with its video, title, long description, etc. Let's see how we're going to implement that. Hello everyone and welcome back. In this lesson, we're going to continue the implementation of our master detail scenario here in our search all lessons screen. So we have here the master part of our pattern, and the search results are stored here in this local member variable. So as long as we stay inside our search lessons component, the results will still be available here. Whenever the user clicks in one of the results on the search list, we want to replace the list with a detailed view of the result clicked. So how are we going to model this in our search lessons component? We are going to add here a new member variable, which is going to be the active lesson. Whenever the user clicks in a result on the list, the active lesson is going to be populated with the corresponding result. This will trigger the replacement of the master view by the detail view. Let's see how this is going to work. Let's start by implementing the logic that is linked to a click on a given detail. We are going to go here to our search lessons component, and we are going to detect here a click at the level of a search result. Whenever this click happens, we are going to be triggering a new component method that we're going to be calling open lesson. To the open lesson method, we are going to pass the lesson that was just clicked. Let's now implement open lesson. This will receive here as input only one argument, which is going to be the lesson that was just clicked. At this moment, we are going to save the lesson clicked on the active lesson member variable. Let's now implement the template logic that is going to show or hide the master table. We are going to be deciding what to show to the user using the Angular ngIf directive as usual. So let's go ahead and add here another ng container element in order to add this extra logic. Let's start by implementing the case when we want to show to the user the master table. So we want to do this if the active lesson is not yet populated. In that case, we want to show to the user this table that we have created before that displays the search results. Now let's see what would happen if there is already an active lesson defined. So in that case, we don't want to show to the user the master table. Instead, we want to show to the user the detail view. Let's then go ahead and create here a new template with the name detail. This will be an Angular ng template element that we're going to give the template name detail. So this name here matches the reference that we are adding here in our else clause of the ngIf directive. So what will be inside the template? The first thing that we want to show is the lesson that the user has just clicked. So for that, we want to be using the lesson component that we're going to be implementing in the next few lessons. Besides the lesson component, we also want to have here a way to go back to the master view. So we are going to be adding here a new button that is going to have the text back to search. Let's make this a material raised button, and let's go ahead and add it a CSS class that we have already prepared. We are going to add here the back button CSS class. Inside our button, to make it clear that it's a back button, we're going to be adding here a material icon with a back arrow. Let's now detect a click on this button. Whenever this button gets clicked, we are going to be calling the onBackToSearch method of the search lessons component. Let's now implement this method. So whenever the user clicks on back to search, we want to hide the lesson detail and we want to show again the search results list. So in order to trigger that, we are going to set the active lesson back to null. And with this, we are almost ready to try out our master detail logic. Let's first finish the lesson component and then try out everything together. Hello everyone and welcome back. In this lesson we are going to finish the implementation of our master detail scenario and we're going to try everything out. So going here to the search lessons component template, we're going to see that we have added here a lesson detail component. This component is going to be a purely presentational component that is going to be responsible for displaying a lesson to the user. So as usual with presentational components, we're going to go ahead and we're going to pass in the data that the component needs to display on the screen as an Angular input. So let's go ahead and pass in here the active lesson. Let's now jump to our lesson component and begin its implementation. So the first thing that we need to define is a member property called lesson. This lesson, as we have seen, is going to be an input for this component. So let's go ahead and annotate it with the input decorator. Now let's take care of the template of the lesson component. We're going to delete this initial implementation and we're going to replace this with a container div containing a CSS class lesson detail that we have already prepared in our sample application. Now let's use an h3 tag and let's display the lesson description, for example. Below the lesson description, let's use, for example, an h5 tag in order to display the lesson duration. Let's then use here the template interpolation syntax and access the duration property of the lesson. Now we are going to display the video that is linked to the lesson. So for that, we are going to be adding here a new iframe, for example, because we are going to be displaying a YouTube video. And let's add here a couple of properties for our iframe. Let's specify here the iframe dimensions. Let's add here a few other important iframe properties that we need in order for the YouTube video to be displayed correctly. And let's fill in the most important property of this iframe, which is going to be the source property. So here we need to point this to a YouTube URL. This is going to be the YouTube URL of an embedded video that always starts with this prefix, youtube.com/embed. And after this, we need to add here the YouTube video identifier that we have available on the lesson property. So let's access here the video ID, which corresponds to the YouTube video identifier. Now we have built here a URL by concatenation. I'm going to wrap the full URL in parentheses, and we now need to inform the Angular framework that this URL is safe. Otherwise, the Angular framework is going to consider that the URL is unsafe and it's not going to apply it to the template. In order to mark this URL as safe, I'm going to apply here an Angular pipe, and I'm going to pass this URL through the safe URL Angular pipe that we have here in our sample application. This is going to essentially inform Angular that this URL is safe to be used as is, and there is no need to hide it from the end user. If you want to have a look at the safe URL pipe implementation, you can have a look at here in our application. We are simply using this Angular injectable, the DOM sanitizer, in order to inform Angular by calling this method bypass security trust resource URL that the URL is safe. And with this, we have completed the implementation of our lesson detail component, and we are ready to try out the whole solution. With the new version of the application already running, let's go ahead and type here a different search than before. Let's use, for example, the keyword state. I'm going to click here on search, and as we can see, we have here 3 results. Let's click here on lightweight state management. If we click on this entry, we are going to see here a YouTube video. We can see here the duration of the video, and we can see here the title as expected. We have now here a back to search button, and whenever we click on it, we are going to immediately show again the same search results. And notice that no loading indicator was shown to the user and that the search results were displayed immediately. This is normal. This is because the search results were still in memory here on this search results observable. Now notice the following: the search results member variable is inherently linked to the lifecycle of the search lessons component. So if we click here on the courses option in our side menu and we navigate away from search all lessons and we go back again to search lessons using the side menu, as we can see now the search results are gone. And if we want to get back the same search results, we are going to then have to repeat the search. Now, if we start clicking on the search details, we are going to see that the results are still there. Notice that not all the lessons have an associated video. So some of the times you are going to click on a lesson and you are going to see here a blank video, but many of the entries that you click, such as, for example, lightweight state management, will have here a video to be displayed to the user. Let's now make a quick summary of the state management solution that we have adopted here in our master detail scenario. So we have used a top-level smart component, the search lessons component, in order to store the data that we got from the backend in a member variable. While this component is around in memory, the data will also be kept in memory and we don't have to fetch it again from the backend. We can then use presentational components in order to display multiple views of the data, either the master table or the detail of a given lesson. In this particular case, in order to share the data between the top-level Smart component and the presentational lesson component, we simply had to use a local member variable and an Angular component input. So as you can see, the data is getting passed to the presentational component using the active lesson member variable. In this particular case, because we were passing data to a presentational component using Angular inputs, we did not have to use a shared service. Notice also that we did not use centralized state management. Instead, we have used state that is only present at the level of a particular component. This has the added advantage that when the component gets destroyed, the state also gets destroyed. And that's a very good feature to have in the particular case, for example, of search results. We would indeed like the search results to get erased from memory whenever we navigate away from the search screen. And with this, we have finished the implementation of our master detail scenario. So what we're going to do next on the next section is, as an exercise, we're going to implement a new screen of our application, the course page, in reactive style, in order to summarize many of the concepts that we have learned throughout the course. Using that same screen, we're going to be presenting a new important design pattern, the single data observable pattern. And in order to conclude the course, we are going to show how easy it is to convert an application written in reactive style to use Angular on push change detection, which is an optimized change detection mode that might be useful for certain applications.